So hello everyone, welcome back to our channel. Today we will be continuing with our dialogue series and the topic of the day is case statements. So without further ado, let's begin. In the last video, we discussed about the if-else construct and we also mentioned that if-else provides a priority logic. But if we have multiple conditions that we have to check and we don't want a priority checking, then we can use the case statement. So what is the case statement? Case statement in Verilog provides a multiple branching mechanism similar to switch statements in other programming languages. This will allow us to compare an expression against multiple case items. Then, whichever the block has the matching that will be executed. Verilog provides three variants of case statement: case, case Z, and case X. When to use these three statements and what are the differences, we will be taking a deep look into them in this video. So the first is the case statement. Case statement, the expression is evaluated once at runtime, then the expression will be linearly compared in order against each case item. If a match is found, the case statement will have a bitwise match including X and Z. Then the corresponding statement executed and the search stopped. If no match is found, then default is provided, then default statement executed. It is not compulsory to write the default statement, but it's a recommendation that you should write default statement. So if in the case that none of the case items are matching, then no latch effect takes place and default item gets executed. Simply put, case will have some kind of expression written here, then it will compare against the case item. If the expression in the case item are met, then that statement will be executed. Now let's take a look at a simple example for this. We have a 16-bit register known as reg A and a 10-bit register result. Now I write case on reg A. That means whatever the value of reg A, based on that output will be selected. Here, if you take a look at it, we are explicitly declared values from 0 to 9. That is, if the value of register is 0, 1, 2, 3, 4, 9, then the output of result, if the value is 0, then the output of result will be 0, 1, 1, 1, 1, 1. Then, if the value of register is 1, then output will be 1, 0, 1, 1, 1, 1. Similarly, like that we have mentioned till 9. But if the value greater than 9 comes in register, then we have also provided default statement that will be executed. The result will be bit X. We have a pro tip here that you should ensure that all expressions have the same bit, that reg A and the case item used here should have same width. As we have mentioned here, the register is of 16 bit and also we have declared 16 width 0, decimal 0, and 16 width 1, 16 bit width 2. Hence, this will not lead to any truncation of bits. We have to avoid using X or Z unintentionally, as they can lead to some errors if they are not handled properly. And we should always use default statement to cover unlisted conditions, especially if we are trying to make the synthesizable design. Synthesizable design simply means the design which can be actually converted to hardware. Now take a look at this example. We have a case signal, one bit, the signal is of 1 bit. We have two case item, one bit BZ, one bit X, and we also have default case item. If the value of signal comes as X, then the output will be displayed as signal is unknown. If the value of signal comes as Z, then this will be executed. What does it indicate? This indicates that case will compare X and Z also properly. So if this was the case of if else, and in the case of if expression we get a x or z, then the else part is executed. But in case even x and z are compared properly, that's why we will get output x and z respectively. So, but if here we have receiving the input as 1 or 0, then the output will displayed as signal is percent %b. Whatever value of signal is there, that will be displayed. Now let's take look at another example. Here I have select of 2 bit, then I have multiple case item. The 2 bit 00, 2 bit 01, 0x, 10x0. What you need to take a look at here? We can have multiple case item giving out a similar result. That is, if I receive 0x or 0z, then I can provide the result as flag A, ternary operator, bit X or Z. What does this mean? Even when the select value is 1, then when the select value is 0, that means this condition and flag A is 0. That means this condition, that flag is 0. Then the result will be 0, even if select value of 2 is X or Z, because all the case here leads to result 0. At 0, if flag is here 0, then also 0. And even if it's X or Z, if the first bit is 0, then the result will be 0 as flag A is 0. Then this case is selected. They demonstrate how to combine equivalent cases with comma separation, as well as we can have conditional X propagation based on our requirement. I hope this example is clear. Now we have case Z statement. How does this differ from case statement? Case Z statement treats Z as don't care in comparison. Also, we can have this question mark character that can be used as synonym for Z in case items. Simply put, if I see a Z or a question mark, the comparison will be skipped, but X will be still be compared, just like the previous case expression. Now let's and if I have two expressions which are matching with the case item, I have two case item that is matching with the expression, then the first match will win. I have an example here. I have declared the expression as 2-bit x0 and I have three case items. 2-bit b1z, xz and z0. So what I mentioned earlier, that in this case, if I see z or question mark, then that position will be ignored. So now let's take a compare. Let's take a two and compare simply. I have one z. First of all, I will compare the first bit. I need to have 1, but here I have x. So the input will fail here itself, as 1 does not equal x. Now, for the second case item, I have x, z. So x and x, the first will be compared and they will pass. Then z and 0. But this doesn't matter. But as I mentioned earlier, if I see z in the case of case z, then that bit comparison will be ignored. Hence, the whole check pass. Now I have z and 0. As I mentioned earlier, I have Z in the first bit, so comparison of the first bit will be ignored, and the second bit matches 0, 0. Hence, this will also pass. Now I have two matches that are passing. So what will be displayed in the output? As I mentioned earlier, then the first match wins. So the output displayed here will be the second case item. XZ matches X, ignores 0. Now I have case X. In the case X, both X and Z are treated as don't care. This is more powerful, but this can be just yet it can mask design problems. In the case where we want to detect X or Z, then we shouldn't use case X or case Z. Then we should go with normal case. But if in design I want to ignore deliberately X and Z, then we can use case X expression. Now here I have another example. I have 3-bit expression 1, X and 0. Now I will compare with the first case I have 1, 0, 0. I compare bit 1 and 1, then bit 1 matches, then the bit second and the first bit I am compared here. I have compared the second bit here is x and 0. It should match, and also 0 and 0. It should match. But here there is a typo. I have written as fails. That needs bit 1 is equal to 0. This is wrong. I have deliberately put it this here. So you should be able to read and understand that, as I explained from the earlier, Once the bit-wise comparison will take place as first bit, then second bit, then third bit. Now for the second case, 1 question mark and 0, then 1 will match. The second is wildcard, that will be ignored, and third is 0, that is also matching. Then in third case item, 1 matching, 0x. Here x, so no need of comparison. Then wildcard, no need of comparison. This is also matching. And I have wildcard, no need to compare, then 0. This is also matching. So ultimately, all the four cases are matching. So you have to comment that you understood this correctly and also point out the mistake that I have deliberately made here. So we can understand you're following these videos with full attention. So ultimately, the what should be the output here? The output should not be B, the output should be A. I hope the explanation is clear. Now, what we have here is the full case. This simply means the case expressions which have the all possible input patterns explicitly covered. That no synthesis won't infer any latches. Now I have a 2-bit select line, but I am not declaring all the case items that 0, 1 and 1, 0 is missing. So this is not a full case. The next we will be having is a parallel case. The parallel case simply means that all case items are mutually exclusive. That is, for one for each expression, I have a different output, but this does not guarantee full coverage. So these are the two types of case expressions which we can use, the full case and parallel case. A case expression can be both full, parallel, or can be none. I hope our discussion on the case statements are clear. If you have any doubts, please feel free to drop them in comments. Thank you.